Today on How It's Made. Solid Tyres, a factory where they set the wheels in motion. Cheesecake, this is no half-baked idea. Canoe paddles, see if these float your boat. And globes, at this factory, they're always on top of the world. But first, the solid rubber tyre is designed for off-road conditions, like construction sites, landfills and warehouses. These areas are full of hazards that would flatten ordinary pneumatic tyres. But solid tyres can't get a puncture. They just keep on turning. And that's good for any job site. No air in these tyres means they're ideal for heavy work. They can move a lot of weight around without buckling. Construction begins with a wide, flat strip of partially processed rubber. A hot extruder forces it through a series of holes. This transforms the rubber strip into a narrower, rounder form. The rubber falls between hot cylinders, where it's rolled out, thin and soft like pastry. In another part of the factory, the tyre's metal framework is prepared. They're moved along on an overhead rail into a special chamber. Steel pellets are shoveled in. Inside the chamber, a machine tosses the pellets about and the friction polishes the metal tyre frames. A coat of primer is sprayed on, and an adhesive is applied. Next, one is mounted on a mechanical arm that's positioned in front of the rubber rolling system. The arm moves the tyre frame forward to meet the turning cylinders. The surface, still tacky from the glue, takes up the freshly rolled rubber. It layers the rubber around the tyre base up to 100 times, depending on the tyre being made. Then it's weighed, and pieces of rubber are sliced off until it meets the right specifications. The solid tyre is now in good shape, so it moves on to the next stage. Over at another station, a different type of solid tyre is being built. This one has no metal framework, so it will fit on a wheel rim made for a pneumatic tyre. Rubber strips are wound around a metal hub that serves as a mould. A bar presses down on the rubber wrap to eliminate air pockets. These rubber strips contain recycled material, which is stiffer. This will help the tyre hold its shape. For these tyres, it's time to get a grip. The process of adding tread to the tyres begins as a release agent is sprayed onto a mould, making it easier to remove the tyre later. The ID label and serial number plate are lightly glued in position for transfer to the tyre. The tyre is then centred in the mould with a metal ring. Then the top section of the mould is lowered onto it. And the mould is hoisted to another station where it's sandwiched between two hot plates. The combination of heat and pressure melts the rubber into the crevices of the mould. The rubber cures in minutes. The process has also vulcanized the rubber, a molecular change that strengthens it. It takes a specialist to change one of these tyres. Using a hydraulic system, he removes the old tyre from the wheel rim and installs a new one. A solid tyre on a wheel rim made for an air-filled one. Large tyres with metal framework go into this autoclave to take shape and undergo vulcanization. A forklift truck, equipped with solid tyres of course, extracts the finished tyres from the autoclave. And now, they're ready to roll. The ancient Greeks served cheesecake to the athletes of the first Olympic Games in 776 BC. The Roman conquest spread the dessert across Europe. These tasty treats have stood the test of time. From New York delis to fancy dinner parties, the cheesecake suits all tastes. The ancient Romans were so enamored with cheesecake that they even brought it to their temples as an offering to the gods. The cheese in cheesecake can be cottage, ricotta, Neufchâtel, or cream cheese. Their base, a buttery biscuit crust, is similar to shortbread. For a batch of about 60 cakes, this bakery combines 23 kilograms of butter with 4.5 kilos of sugar. Next, 16 egg whites. Then 11 kilograms of flour. After mixing just long enough to incorporate the flour smoothly, the dough is transferred via conveyor belt to a vat. Gravity pushes the blob of dough out through a slot at the bottom, expelling a dough sheet about 0.5 centimeter thick. A dusting of flour prevents the dough from sticking, not just to the conveyor belt, but also to the rolling and cutting tools. This prickly roller perforates the dough sheet. The holes enable trapped air to escape during baking, which prevents the dough from shrinking and ensures a flat, bubble-free crust. The next roller has plastic circles which slice the dough into cake-sized discs. The leftover pieces go into a new batch of dough. Each dough circle goes into a pan, then bakes at 190 degrees Celsius for 16 minutes. Meanwhile, the batter takes shape. For a batch of about 20 cakes, the bakery combines 11 kilograms of cream cheese with a kilo of cultured sour cream. That's sour cream processed a little longer than usual to give it more flavor. After slowly mixing in 7 kilograms of sugar and around 2.5 cups of flour, 3/4 of a cup of vanilla extract is blended in. Then it's time to get cracking with 18 whole eggs. That's the recipe for plain cheesecake. Flavored versions contain extra ingredients. This batter is caramel pecan. It goes with a chocolate crust. As the baked crusts arrive, sprayers grease the inside of each pan with butter so that the cake will slide out easily after baking. Then a machine called a depositor shoots in just the right amount of batter. The pans now enter a tunnel-shaped oven that's 21 meters long. The temperature inside is 177 degrees Celsius. By the time the cakes exit the other end, they're fully baked. These 25 centimeter wide cakes take just under an hour. From the oven, the cheesecakes go onto a cooling conveyor. By the time the hot cakes, up to 2,000 at a time, have completed the nearly hour-long circuit, they're at room temperature and ready to come out of their pans. From there, it's straight into the storage freezer, except for certain fancy cheesecakes, which detour to the decoration department. This Belgian chocolate cheesecake gets a big squirt of chocolate ganache, a decadent mixture of chocolate and cream. It's spread all over before swirls are made with a decorating comb. And now the final touch, a sprinkling of cocoa. Certain orders go into an automated cutting machine that divides each cake into 14 equal slices and inserts grease-proof paper in between them. Back at the decorating department, they're putting shards of chocolate on a mud pie, a combination chocolate soufflé chocolate cheesecake with pecans and a coffee mousse topping. You might want to put off that diet for just one more day. Coming up on How It's Made, canoe paddles. Don't get stuck up a creek without one of these. And globes. We nip down to a factory that should be world famous. See you after the break. Welcome back to How It's Made. The simple paddle is made with sophisticated craftsmanship. Today's wooden paddles really go the nautical mile. They keep us from going adrift, and no one wants to be up the creek without one. Let's face it, your canoe is going nowhere without it. With paddles like these, you really can go far. These days, paddles are often a blend of hard and soft woods, giving a result that's strong yet lightweight. The boards are fed into a multi-bladed ripsaw that slices them into a uniform strip. Each strip has a flat, smooth joint on the side. Glue is rolled onto these flat joints and then strips are pressed together. These glued sections will be used to make paddle blades. Over at another station, they're working on the paddle shafts, 2 at a time. Shorter pieces of wood, which will become the handles, are glued and clamped together. The blade chunks are arranged in a much larger clamp. Then the glue-coated ends of some shafts are wedged between the blade pieces. In a process called lamination, the blades are bonded to the shafts. The laminated paddle shapes are called blanks. The blade design is penciled onto one of the blanks. The design is cut out using a bandsaw. Laminated wood doesn't warp easily, which means the paddle blade can be made wider to give more power to the user. The more traditional look and feel of paddles cut from single pieces of wood are still favoured by some. This narrower paddle has been cut from a piece of cherry. Modern tools make quick work of a design that's hardly changed over the centuries. In no time, the basic paddle has been carved from a single piece of wood. A large router is used to round it off. It shapes and contours the paddle to its final dimensions and gives it a smooth finish. In just minutes, that chunky-looking paddle is transformed. Meanwhile, back in the laminated paddle department, a saw cuts slots in the tips of each one. A liquid plastic concoction is mixed up. Then it's poured into the slots where it hardens. The plastic gives the paddle tip some extra protection. Now it's time to improve the profile of the laminated paddles. With the same type of router used to shape the solid paddles, the design is fine-tuned. Both types of paddle then get a heavy sanding. Each one is tapered so that it's much thinner at the tip. trademark information is branded onto each paddle using a hot iron. Then it's time for the paddles to take a dip in a tank of varnish that contains a sunblock. The varnish both protects the wood and enhances its natural beauty. The paddles are suspended on an overhead conveyor. And soon they'll be on their way to a waterway near you, where they'll be sure to leave ripples of approval in their wake. Because the world is round, flat maps don't give us the full picture. A globe gives a more accurate impression of the world. It depicts countries in true spatial relation to one another and better defines lines of latitude and longitude. Globes really give us a well-rounded view of our planet. At the Globe Factory, production revolves around world events. As wars and political upheaval redraw boundaries, these spherical maps are revised accordingly. Making a globe begins with a large roll of cardboard. A machine pulls it under a roller that coats it with glue. A knife then slices the cardboard into smaller pieces, which will serve as liners for the maps. One more coat of glue, and then the liners are stuck to the back of maps. Heated rollers press them together, completing the seal. Each map is of a hemisphere. A powerful press now cuts the maps along pre-marked lines. Each map is carefully positioned in the cutting press. After all, one false move and they could lose parts of Japan. It takes 2 punch cuts to do the job. The excess paper is pulled away from between the 12 spoke-like sections of the map. Here's a top view of that cutting press. It acts like a giant fist to punch out the maps. And now, it's time to shape the world. A map cutout and a separate liner are placed in a mould of half a globe. It rises into a heated cavity where it's pressed into a bowl-like shape. Now they have a hemisphere. But of course, there are 2 in every world. At least mine. The southern hemisphere is made using the same type of mould. The moulds also emboss each map to signify peaks and valleys on the Earth's surface. Here's an inside look at those moulds. The raised and indented sections make impressions on the globes. They allow people to see and feel variations in the world's topography, both above ground and underwater. The hemispheres are complete, and it's time to go global. A northern hemisphere spins while a razor blade trims the edges. Then a lower hemisphere goes for a spin, while a nozzle beads hot glue along the inside. This stiff cardboard ring adheres to it and gives the hemisphere some reinforcement along the equator. Glue is applied to the northern hemisphere, and it fits over the ridged edge of the southern one. The 2 halves are precisely aligned, and tape is added over the seam. This disguises it and marks the equator. Next, each globe is mounted on a pedestal that's attached to a metal arc called a meridian. Suction to the top of the globe, the meridian will allow it to revolve. From fragments of paper and cardboard to a globe. This world was made in just a couple of hours. Globes tell us where we are in the world and help us figure out where we're going. Globes are produced in many different languages because there is, well, a worldwide demand for them. And because they help us get our bearings, you could say they make the world a better place. So, whether it's a tiring process you're interested in, or perhaps a recipe courtesy of ancient Greece, or you just fancy going for a paddle, now you know how it's made.